Okay, students, we'll begin with the next chapter, that is object design. Now, object design comes immediate after system design. It includes reuse. Now, in reuse, we try to identify off-the-shelf components and design patterns to make use of existing solutions. It also includes service specification, where we precisely describe each class interface. Object model restructuring is included in object design. By this we mean to transform the object design model to improve its understandability and extensibility. Furthermore, we have object model optimization, where we transform the object design model to address performance criteria such as response time or memory utilization. Here we have an overview of object design. Object design is actually the process of adding details to the requirement analysis, and making implementation decisions. The object designer must choose among different ways to implement the analysis model with the goal to minimize execution time, memory, and measures of the cost. Requirement analysis has to be carried out here. In requirement analysis, we make use of use cases. Functional and dynamic model deliver operation for object model. Why we are focusing on analysis model here? Because in this analysis model only, the functional and dynamic model will deliver operations for the object model. Object design iterates on the models, in particular the object model and the refined model. Object design services as the basis for the implementation stage. First, we will see at refining the application domain objects here. While refining, new objects are often needed during object design. When we try to refine the application domain objects, there may arise a need of new objects to be defined. The use of design patterns introduces new classes. The implementation of algorithms may necessitate objects to hold values. New low-level operations may be needed during the decomposition of the high-level operation. Let us have a look at the example to better understand what we mean by refining the application domain object. So consider we have an operation called as erase an area. Erase area is the name of the operation in drawing program, where we are drawing something over the canvas. So conceptually it appears to be very simple. Its implementation includes area represented by pixels. Where you want to erase a particular area, you should have an operation called as repair, which actually cleans up partially covered by the erased area. Which actually cleans up the objects which are partially covered by the erased area. We also need to have an operation called as redraw, where we draw objects uncovered by the eraser. And again, we have a draw operation that erases the pixels in background color, which is not covered by any other object. Now these are the activities which are included in object design. First is select the subsystem. Here you have two things to be specified. the specification and reuse. Both of these stages, they are dependent over each other. Now the specification includes identifying missing attributes in operations, further specifying the visibility, specifying types and signatures, specifying constraints if exist, and specifying exception conditions. Reuse includes identifying components, adjusting components, identifying patterns, and adjusting patterns. This is the part 2 of the activities. After specifying and following the reuse activities, we have to check the use cases here. Now this arrow and having a double circle indicates the end of the procedure here. So you need to check the use cases. Now there appears a condition. If a condition is no, you have to trace back to the initial stage and carry out the operations from there. If not, then we'll go for restructuring. Now, restructuring includes revisiting inheritance, collapsing classes, and realizing the associations. And then we go for optimization. So optimization include your optimizing the access path, caching complex computations, and displaying complex computations. Further, a certain condition is reached, and we can go back to check use cases again. If the condition is met, the procedure may end up. Now we'll have a detailed understanding about the reuse concept. The main goal of reuse is to reuse the knowledge and functionality from previous experience to current problems. The approaches may include inheritance and delegation. By inheritance, we mean making use for the concept classification based on the type hierarchies. Implementation inheritance make use of the code reuse. By implementing the inheritance, we actually make the use of the existing code. Now delegation includes here an alternative to implementation in inheritance, where we are also using the code again, the existing code I mean. Now there are objects that appear in application and solution domain. So application objects are also called as domain objects. They represent concepts of the domain that are relevant to the system. They are identified by the application domain specialist and by the end users. Whereas solution objects represent concepts that do not have a counterpart in the application domain. They are identified by the developers only. Examples include persistent data stores, user interface objects, and middleware. Now here's an example. Here we have requirement analysis, that is language of an application domain. We have an incident report here as the application domain. If we look at this and try to find the solution domain for the corresponding one, it includes incident report form, which further has text boxes, menus, and scroll bars. Now, specification and implementation inheritance. We'll first look at inheritance is actually the generalization. We can even call inheritance as considering an object-oriented concept such as superclass and base class, and specialization as subclasses or derived classes. Now, the goal here is to reduce redundancy. Those things we want to minimize that are getting repeated over time again and again. And also we need to focus on enhancing the extensibility. These are the two goals here. Factoring all redundant behavior in a single superclass reduce the risk of introducing inconsistencies during changes. Make changes only once for all subclasses. So here what we will be doing, we will be factoring out the redundant behavior. We will combine this behavior into a superclass by so whenever we need to make changes during the stage of changes, we will not face any inconsistencies because we will have to make change only at once where we have combined all of those redundant behavior into a superclass. So all that you need to do is that make changes for that superclass only, and it will be reflected in the subclasses. So we have an added advantage of inheritance here. Providing abstract classes and interfaces used by the application. We can write new specialized behavior by writing new subclasses that comply the requirements here. So when we are following inheritance, we can write some new methods, some new specialized behavior into the subclasses or derived classes. So that will obviously make those subclasses specialized ones. Now here we have an example of inheritance that is being used to achieve two different goals, taxonomy and reuse. Look at the figure carefully here. At the very root level, we have inheritance. Inheritance. So this is the superclass here, we can say. At the lower end, we have here taxonomy and inheritance for reuse, which further includes, now taxonomy further includes inheritance detected by specialization and inheritance detected by generalization. So actually when we are looking at two different goals, when we are using inheritance to achieve taxonomy, so this is included under analysis activity. When we want to implement inheritance for reuse, it is actually an object-oriented concept. So when we are using inheritance for reuse, it includes inheritance, interface inheritance and implementation inheritance. Further, we are taking taxonomy example as mammal. So mammal, if we look at tiger, tiger is also a mammal, wolf is also a mammal, and whale is also a mammal. But they do have different characteristics. So they become the derived class, whereas the common features are categorized under this base class or superclass mammal here. Further, if we take another example, so consider writing an application manipulating images in terms of an abstract image class, which defines all the operations that all images should support. So here we assume that we are writing an application to manipulate images. So what are the whatever the basic operations that manipulate images should be supported by all of the images here. So we are trying to write those applications here. Then write a series of specialized class for each image format supported by the application. Each image format, we have various image formats such as we have JPEG, we have tag file images, we have GIF images, and so on. So if we write a series of those specialized classes, they will be supported by the application for various types of image formats. When we need to extend the application to a new format, we only need to add a new specialized class. See, this simple it is. If we go for inheritance, all of the basic operations will be included in the base class, superclass. Whereas if we later in this stage, if we realize some new extended functionalities to be added, then we can simply add a new specialized class to it. Implementation inheritance further describes the use of inheritance for the sole purpose of reusing code, and that is actually called as implementation inheritance. So implementation inheritance, the sole purpose is for reusing the existing code. Instead of going for a new code to be written, what actually we have in hand, why not to use it? Developers reuse code quickly by subclassing an existing class and refining its behavior. So if developers are having a ready to use code, they can simply do some of the manipulations with the existing code and refining its behavior and can use it. So it becomes easy for the developers. Classification of concepts into type hierarchies is called specification inheritance. Implementation inheritance include reusing the code. Specification inheritance include we are trying to classify the concepts based on type hierarchies, and it is also called as interface inheritance.